Okay, we're talking about matrices. There's a movie called The Matrix, and it's a whole bunch of numbers that are like running down the screen, and they're always in a rectangular format. I don't know if you ever noticed that, but basically, they have kind of streams of numbers in the background of this. Is kind of cool. Those are columns of numbers. One of the most tricky things about matrices is they're always in rectangles like this. Like here's a matrix, and it's in rows and then columns. So carefully think this through. I want you to tell me how many rows by how many columns this is. Like, is it 4 by 2? Is it 3 by 1? Carefully, and I encourage you to think in terms of columns as like things that hold up buildings. So these blue things are either rows or columns, and these green things are either rows or columns. And columns hold up buildings. So is this, since it always has to be R and then C, how many rows does it have? How many columns does it have? I'm going to pause for a second. Let me try that. All right, so by now you should have figured out that this had how many rows? 2. How many columns? 3. And it's easy to get those backwards, but you got to get it straight. The columns are the up and down. They hold up buildings. But you always do rows first. But rows, I mean, I really could see how a person could get this confused, because a row, you can actually refer to these as rows when they go up and down, even though they're columns. Like, for instance, in this room, haven't I referred to this over and over again as like row 6? Even though from my perspective, it's actually a column because it's going up and down. See what I'm saying? So rows and columns are easy to confuse. The columns are the ones that go up and down. Columns hold up buildings. All right. So this one, looking at this one, it's very similar to the one in fact, I think it might be identical. It has 3 columns and 2 rows, but you always do rows first. So it has 2 rows by 3 columns. Okay, moving on. Would you quick, underneath each of these, write row by column, like 2 by 3, or 4 by 6, or whatever they are. I'm going to pause while you try that. You should have said, this one had, I like to do the columns first, even though they have to be listed second, because it's always rows, then columns. There's 3 columns, and then 4 rows of 4 by 3. Raise your hand if you had 4 by 3 on that one. Good. This one should have been 4 by 2. This one should have been, how many rows? 2 by 4. And this last one should have been 3 by 2. Raise your hand if you had all of those right. Awesome. Then, if the matrix has the same number of rows as columns, it's said to be a square matrix. As in, if it's 3 by 3, they're also a little more, well, they're less confusing, because you can't screw up the rows and the columns then. You know what I mean? If it's 3 by 3, you can't put it backwards by accident, right? So the square ones are the easiest, and you see a lot of square matrices out there. Now, this is a little more complicated, and I don't like the way this starts off, and so I'm just going to say this looks like A11, but it's actually said A11. I want you to think about why. It's because it's in row 1 and column 1. This little a is in row 1 and column 2, so that's not A sub 12, it's A12. Okay, notice this is a big A. That stands for the whole matrix. The little a's are on the inside. Those are called elements. And each little element then can be described with a number. So for instance, if we're over here, this spot right here, the 12, could be thought of as a little a with a row what and column what? Row, these are rows, row what? 1, column what? So that's A12. I wouldn't mark you wrong if you had said it A12. You're not going to be saying it anywhere, writing it on a test, so it doesn't matter that much. But just don't think of that as the 12th entry. It's not A12. It's A12. Row 1, column 2. All right, would you please figure out where the 15 is? You do not have to do all of them. Just tell me the 15. The 15 is A, what? Don't say it, write it. I'll pause where you try that. Oh, and down in this one, we're going to do one way where I say this is the 19, and how would you write it? And then I'm going to say another one. What if it was talking about A31, which value is it? Can you go backwards? I'll pause for a second while you try those. Okay, if you understand what we're talking about, the 15 here, it's in row what? Column what? So it wasn't really a great one because you could have said it backwards and I wouldn't even know, right? Doo-doo. All right, number 19, that's this one. That's in B. Did anybody notice this changed to B? I bet a lot of people wrote A. It's okay, you're human, follow patterns. This is a B here. How many caught the B thing? Usually only there's a couple people. Ah, 2 people. All right, see, you're normal. It's okay. Then B, and it's either 1, 1 or, oh no, wait. It's row 3, column 1, B31. Is that correct? Okay, good. All right, let's do one more for good measure. If I put -6 right here, how could you describe it? Don't say it in words, write it down. And I'm going to ask you in a moment to compare with the kid next to you. Use a little b. Compare with the kid next to you. Right, anyway, so the -6 here, that should have been described as a little b because we are in matrix big B. And little b, and then it's row what? Row 4. Column what? Column 2. B42, raise your hand if you had that one right. Okay, awesome. I think you get how to describe these things, which is good. Next, the excuse me, adding and subtracting is so easy. That 3 goes with that 4. And then, therefore, they make a total of, wild guess, 7. And don't put commas. Oh, it's so common that people put commas, but don't. In matrices, you don't. You do need to leave some space so it doesn't look like one big number, but 2 and 8 makes 10. So, like, if you write this, you go, is that 710 or 710? Or, so leave a little space. 710, and then what's these last 2 make?
17.
There you go. That's all there is to it. And subtract is that easy also. I don't want to rewrite this whole thing, but I'll just do the first part. 1 minus 3 makes -2, and then you just keep going like that. 5 minus the 2 makes 3, etc. Get the idea there? Adding and subtracting is your happy place. So easy. Multiplying, also extremely easy on this level, where you just scale it up. That means everything gets scaled up to be 3 times as big. It's as simple as you would think. That's 21. That's 3 times 2 is 6. That's 3 times -4, -12. And 3 times 0 is a little weird. It's 0. 3 times as big is still 0. Right? Okay, so 21, 6, -12, 0 would be your answers. All right, one thing, never put giant parentheses around these. That would totally change the meaning of it. Just don't use parentheses. Use brackets. Okay, next. This one's got a weird 1.5. I don't like that. Let's just change it to -2 because it's so much easier to do in your head. Now notice, you'll have nice decimals if you are to have to multiply, but it'd be like 0.5 or something. All right, that times that. Oh, that's pretty easy. And then you add that times that. Would you just get the first 2 spots? I will describe them to you officially as A11 and A row 1 column 2 A12. Just find those 2 spots. A11 and A12. So just to make sure you're doing it right, if you did A11, you should have had -2 plus 0 is -2. How about on A12? What did you get? Yep, front row.
Okay, so I multiplied -2 times -6.
Okay, -2 times -6 makes, okay, 12, and then 5 times 4 is 20. 20 and 12, 32. Raise your hand if you also had 32. Okay, good. These are really easy. Cool. Now, it gets more complicated, of course. So, this is a matrix that's coming from a set of equations. Can you just look at it quick and see, can you see where they got the numbers from? They pulled a number out of everything. On the ones that have a variable, the number in the front is called a coefficient. The 2, the 3, and the what? There wasn't even a number there. That means there's a 1 there, right? Little things you're supposed to know by now. Those 3 are called the coefficients. The ones at the end don't have a variable. Those are called, anybody know what they're called when they don't have a variable? Has a con in it. Constant. Yep, those are constants. These 3 are constants. The other ones are coefficients. Anyway, all you have to do is take the numbers and make a big matrix out of it. Well, what's cool is that this would have been a real pain in the butt to solve with a whole bunch of swapping out like x is equal to z plus 4, and then you'd solve by sticking in, it's called substitution. You'd have to do a whole bunch of substitutions, and you'd finally, after a ton of work, know that like x was 5, and then you'd have to like do it all over again and solve for y, and then do it all over again and solve for z. The cool thing is, if you just put all that into a matrix, you can hit one button on your calculator and it'll solve the whole thing and tell you what x, y, and z are. That's powerful, because that's an ACT type question. That's the type of thing that would take a lot of people 8-10 minutes on their ACT. But if they knew how to do it with matrices, they could just hit one button, it tells you the answer. X is this, Y is that, Z is that. They'll do that by the end. But for today, all you have to do is set up the equations. So like for instance, you get how that is a matrix waiting to happen? Would you please make me the matrix? All you're doing is pulling numbers off. 22, 1, 232. Get where I'm going there? All right, Mr. JP, tell me what the next row is. You are correct. There we go. I made a matrix out of it. And then, if I hit the right button on the calculator, after I type that in as a matrix, then it'll give me the answer. Some things you'd have to know to be able to put this in your calculator. It's going to ask you how many rows, how many columns, and if you get them backwards, it's all going to be wrong. So is this a 2 by 3 or is it a 3 by 2? Think before you answer. Do you agree it's a 2 by 3 matrix? All right, you're going to have to tell the calculator, I want a 2 by 3 matrix. It'll pop one open with a bunch of empty spots. You type in these numbers, and then you hit this special, don't grab the calculator. We're not even doing them today. Just telling you how to set them up, because today's got enough to do. All right, because of course, they get harder. So moving on to this one. This actually isn't any harder, just more numbers, so I'm not even going to do it. I'll not ask you to do it. I mean, I'll just do it myself. It'll be 1, -1, 1, 10. Get the idea? It's just got more numbers. All right. So how about this kind? What's different about it? It's got x, y, and z, but they don't all have an x or a y or a z. Sometimes they only have 2 of them. So here's what you do. You think of it in terms of, this has got 1x plus 1y plus, noticing that there's z's in these guys, I would say it's got how many z's? 0z. Do you see how that holds the place? I make a little slash through my z's so they don't look like 2's. Equals, and then a constant, which is 0, but we don't have to put that in the matrix. No equals in the matrix, but all I did is change my equation so it had x, y, and z, and it put them in the right order. Look how math is important, that we keep it in the right order. All our x's need to be first. All our y's need to be next. All our z's need to be next. And then the constants at the end, there's a name for that. It's called standard form. Math's supposed to be that way. You're supposed to have all your x's first, then your y's, and then it equals a number. You can solve for y if you want to later, but in standard form, that's what you need for a, sorry, I gotta say that over again. To put something in a matrix, you want it in standard form. Write me one the right way with x's, y's, and z's. Use 0 of them if necessary. And write me this middle equation right here. I'm going to pause. We try that. Did you say there's 0 x's plus 1y plus 1z was equal to 3? Raise your hand if you had that one right. Awesome. Now that it's all lined up and everything, you could put it in a matrix really easy. Let me finish this. This one had, notice the x's were last, negative x. I could see a lot of people goofing that up. Got a negative goes with it. Okay. And then there's no y's. And and then there's 1z, and it equaled 2. Do you get the key was that the negative x had to go to the front? Because you always have x's first. Okay, then, now that I've got them all lined up that way, we would pull this and get 1, 1, 0, 0. Where'd I get that? All the numbers from the top row. 0, 1, 1, 3. Once you got it written like this, it's so easy. There we go. All right. And then once it's in the calculator like this, I'm telling you, there's just one command. It's called RREF, which is you're telling the computer, I want you to reduce this to row echelon form, RREF. You will not be expected to memorize what those words mean, but it's called reduced row echelon form, and RREF is the command you would need. Once this is in the calculator, that button, RREF, blink, and then it just solves it. It is so quick. It's really cool. Okay. How about if we go backwards? Do you get that this could be a system of equations? Let's not do the whole thing. Just do the top row. What would the equation be that would go with that? Say it. 0 z equals 4. Very good. And then you could write all three equations like that. All right. Moving on. Last thing we got to cover is equations for shapes. That's kind of weird. This is how, when the first video games were being programmed, this is how they programmed them. They took the corners of the little thingies and made them into a matrix, which you could put into a computer. Now, granted, you probably wouldn't just want to have a little square. Although the very, very first video game was Pong. It was like a square, and then there was another square over here, or okay, it's a rectangle, sorry. And there was a ball, and the ball had like some physics properties, and as in if it was coming this way, it would bounce off the paddle and go that way, and then the other person had to move the paddle over to the other side. And anyway, but do you get that your paddle had to move, otherwise this isn't a very fun game. So your little rectangle thing needed to be able to move left or right. So all you'd need is the four corners, and then you'd need to take those four corners and be able to tell the computer shift it right or shift it left based on the inputs that the person gives it from the joystick. Okay, so how do we do this? It's simple. These points, you're going to be tempted. Now listen to this. You're going to be tempted to list them like normal. -3, 0, like in an XY chart, remember? You don't list them like normal. I'm going to list them like normal at first and then show you how you actually list them. But again, I didn't say this well last hour. I just left them thinking that that's how you make it a matrix. But that's not how you make the matrix. That's a list for an XY chart, but here's how the matrix would look. See if you catch on what I'm doing. Do you get you do not list them this way, but you do list them that way? So what's the whole top row it's called? Those are all the x's. Okay. Do we still have little points? Yeah. Like 3, 1 was on my list, and it's still here. It's just written that way. Get what I'm saying? All right. If you understood that, would you please write the correct way to write the matrix for that? Don't make an XY chart, unless you want to start with an XY chart and then change it. So here's how you do not write it. -3, 1, 1, 3, 2, -4, because that would have been like an XY chart. Instead, you should have said -3, 1, 2, and then 1, 3, -4, and all your points are still there. Like, for instance, the point 2, -4, which was down here. He's right there at the end. Any questions about that? What do you think happens This is kind of cool. If I do a 2 out front, it stretches it in both x and y direction by making all the points double. You know what I'm saying? So all of a sudden, it's a much bigger triangle. That makes sense? What do you think would happen if I put a 1/2 in front of it? It would shrink everything in both x and the y direction. Yes? Does it matter what order you put the points in? Good question. No, it does not. In other words, if you had put that point last instead of first, totally okay. And that's a very valid point because I just picked a capricious, like I picked this one to be first. Just because it was on the left, it doesn't have to be on the left. That point could have been moved over and have been fine. Now you do want to keep these together because, you can't shuffle your x's and y's up. All right, moving on. If we were going to graph this one, all I really need to know is that's a point. Graph it. Everybody do that. Graph that point. And then, oh, that's right. Your stuff isn't movable, is it? I can grab this and slide it over. You guys can't do that, can you? Okay. Then I guess just graph the 3 points, and then I'll slide that out there. -3, +2. Still a graphing test to make sure you still know how to graph. Over 1, up 3. Over 2, down 2. Do you get that lines up perfectly with this? Okay. So there's your original points. Now, what does it say to do to it? Left 3 and up 2. Now, for me, as dragging something, that's really easy. Left 3, do, up 2, do. There's my new triangle. I moved it left 3 and up 2. But for you, on a test, you can't just like drag it over. You got to actually move each point and make the dots, and then you could list them. What's another way to do it? Take each of your x's and move them to the left 3. Take each of your y's and move them up 2. That means add 2 to this and left 3, subtract 3 from those. And this is the first time where that whole inside-outside thing doesn't work anymore. But there's really no inside or outside. You get what I mean? The x's and the y's, they're not like inside versus outside. So therefore, it seems like -3, and it is -3. You just simply subtract 3 from all of these. That becomes -6. 1 minus 3 makes -2. 2 minus 3 makes -1. And then I do my y's. I'll do them in a different color. I'll do blue. 2 plus 2 is 4. 3 plus 2 is 5. And -2 plus 2 is 0. And there's my new points. These points go with that. So I could just do stuff to the x and different stuff to the y. All right. There, you've learned everything. Now, again, this is an example where if I times everything by 2, what do you predict would happen to my triangle? Get bigger. That's called a dilation, officially. All right, moving on. Your homework's one of these. Remember, you're going for a 70. I think it's if I can't get a 75 out of it, then I'll make it 70. You know what I mean? Like if the numbers don't work out nice. A 70% is even okay if the numbers aren't working out nice to get an A. So don't expect perfection. That also means I don't want you to come up and say, Mr. Server, on this one, I really meant to put this, and so can you please? I'm not going to make tons of individual little, I'll give you credit for that. Because you get 70%, 70 to 75% in that zone gets you a straight A. Again, if the numbers work out nice to make it 75%, that's what I go with. Like if there was 4 questions and you got 3 out of 4, that'd be 75%. All right, that's all I got for you for today.